Alright, so if we look at 9.2, we're going to look at arithmetic sequences and partial sums. So the first part of the assignment that we're going to look at is we're going to look at what an arithmetic sequence is. And just based on the name arithmetic sequence, it seems to make sense that it is a sequence where you add or subtract some common number, which we call our common difference, and we label D.
How do you say that?
Arithmetic. It's spelled the same way as arithmetic, I know.
Okay.
It's just pronounced differently. Sick. Alright. So if I look at example 1A, I'm given the sequence 7, 11, 15, and 19, and I need to determine if it's an arithmetic sequence. You have to find your common difference. Okay, so what do I need to do to get from 7 to 11? Add 4. Okay. And from 11 to 15? Add 4, and from 15 to 19? Okay. So my common difference is positive 4. And yes, this is arithmetic. That's it. Yeah. Pretty simple stuff. Oh wait, so do you guys want to do another one like that, or does that make sense? Good? Okay. Alright, the second thing then we're going to look at is the nth term of an arithmetic sequence. Okay, and so previously on your last assignment we had you do this via guess and check. Today we're going to actually look at the formula for the nth term of an arithmetic sequence. Okay, so to find your nth term, a sub n is equal to a sub 1 plus n minus 1 times d, your common difference. Okay, so a sub 1 is your first term. N is the number you are looking for. And D is your common difference. Okay. So if I look at example 2a, I'm asked to find the formula for the nth term of a sequence with a common difference of 3 and a first term of 2. So I know my a sub 1 is 2, and I know my common difference is 3. So if I plug those in, I get a sub n equals 2 plus n minus 1 times 3. And then we're going to simplify. We're going to simplify by distributing backwards. So 2 plus 3 times n is 3n. 3 times negative 1 is negative 3. And then if I combine my like terms, 2 minus 3 is negative 1. So my nth term formula would be negative 1 plus 3n. Or you can write it just 3n minus 1. Okay, so if I do another one like that, where I have a common difference of 5, and the first term of negative 1, I'm going to use the same formula, a sub 1 plus n minus 1 times d. And if I plug in my 1 and my 5, I I get a sub n equals -1 plus n minus 1 times 5. And if I backwards distribute, 5 times n is 5n. 5 times 1 is -5. And -1 minus 5 is -6 plus 5n. Okay, so far so good. Okay, arithmetic sequences are also called recursive sequences because your next term relies on the term in front of it. And so we're going to look at some recursive sequences today as well. And the formula for a recursive sequence is a sub n plus 1 equals a sub n plus d. Okay. So if I'm given a sequence with an a sub 1 of 3 and a common difference of -3, and I'm told it's a recursive sequence, then that tells me that a sub 2 is going to equal a sub 1 plus d. And I want to find my next 3 terms. And so then the same would follow for a sub 3 is a sub 2 plus d. And a sub 4 is a sub 3 plus d. Or you take your following answer and plug it into your next one. So if I want to find a sub 2, I know that's a sub 1, which is 3, plus my common difference, which is -3. And 3 plus -3 is 0. So then to find a sub 3, I take this 0 and I plug it in for a sub 2 into my second equation. So then I end up with 0 plus -3. And 0 plus -3 is -3. And then you do the same thing to find your a sub 4. You have to take your a sub 3, so -3, and plug it into your last equation. So -3 plus -3, which gives me -6. Alright, we're also going to look at today at the sum of an arithmetic sequence. And we're also going to look at partial sum. So this is for a sum or a partial sum of an arithmetic sequence. Okay, so the sum of an arithmetic sequence with n numbers of terms is equal to the number of terms divided by 2 times your first term plus your last term. Make sense? Okay. Alright, so if I look at example 6a, I'm asked to find the sum of the integers from 1 to 100. So I'm finding the sum of n terms is equal to n divided by 2 times a sub 1 plus a sub n. Okay, well I know I'm starting at 1, so my first term is 1. And I'm ending at 100, so my a sub n is 100. And then to find your number of terms, how many numbers are in between 1 and 100? 100, so n is equal to 100, because that's the number of terms you have. So if I plug all that in, the sum of this sequence up to 100 is equal to 100 divided by 2 times 1 plus 100. Okay, well 100 divided by 2 is 50. 1 plus 100 is 101. And so 50 times 101 is 5,050. So if you were to add up all the numbers in between 1 and 100, you'd end up with 5,050. Okay, and so that would be a complete sum. We're also going to look at some partial sums, where we're given a sequence that never ends, and we're asked to find the partial sum up to a certain number. And so if I'm asked to find the 150th partial sum, my n is going to be 150, because that's the sum I'm trying to find, of this sequence 5, 16, 27, 38. I also know my a sub 1, because that's my first term. What I don't know, somewhere out here, is my a sub n, my 150th term. So that's what we're going to find first. Okay, and so to find any nth term, you use your nth term formula. So I know I'm going to find my 150th term. So a sub 150 equals, well, my a sub 1 is still 5. I'm finding my 150th term, so 150 minus 1. And then what's my common difference? What do I do to get from 5 to 16? 11. Okay, so if I simplify all of that, 150 minus 1 is 149. And what's 149 times 11 plus 5?
16.
1,644? Okay. Okay, so I know my 150th term, which is my last term, my sequence, is 1,644. And now I do the other formula. So the sum of my 150th term of this sequence is equal to the number of terms, so 150 divided by 2, times my first term, which is 5, plus my last term, which is 1,644. Okay, well, 150 divided by 2 is 75. 5 plus 1,644 is 1,649.
1, 2, 3, 6, 7, 5.
So my partial sum would be 123,675. Okay, do we want to do one more like that? No? Yes? No? No? Okay. I'm seeing a lot of head shaking no, so I'm going to assume that means we're ready to start. So 657, 5 through 31 odd, 41 through 45 odd, 51 through 54, 59 through 62, 67 through 70.